So let's have a look at question 12d from the 2014 National 5 Physics paper. It says, at launch, the initial upward thrust on the rocket is 370 newtons. So this is the water rocket in question. Calculate the initial acceleration of the rocket. So we have our initial thrust. So I'm just going to quickly again draw the rocket here. So it looks something like that. There are 3 fins, but I'm only going to draw 2. And there's the water shooting downward like that. It says calculate the initial acceleration of the rocket. So the key equation here is that the acceleration is the force over the mass, A equals F over m from Newton's second law. But this force has to be our unbalanced force. So if we just calculate that, first of all, the unbalanced force is the difference between the weight, which acts downward, and the thrust, which is acting upward. And I'm just going to get rid of that because I need to say it's thrust minus the weight. If the thrust is going up and the weight is going down and the unbalanced force is acting upward, then the thrust is bigger than the weight. And so we can determine the unbalanced force by subtracting the weight from the thrust. So that means that the unbalanced force is 370 minus the weight. And if we remember from the previous question, the weight is 9.2 newtons. So if we do that calculation, we find that our unbalanced force is 360.8 newtons. So we can use that with the mass of the rocket to determine the acceleration. So the mass isn't given in this question, so let's just have a quick look back and see if we can find the mass. It says that the mass of the rocket, there it is 0.94 kilograms. So back down to where we were solving the problem, like here, and then we can say that the acceleration is the unbalanced force, which is 360.8 divided by the mass, which was 0.94. And so if we do that calculation with a calculator, we get a value for the acceleration of 380 meters per second squared.